William Gilpin is an applied physics researcher at Stanford with an interest in fluid dynamics, and one thing he'd long noticed.
Fluids really naturally have this property of hiding information, of mixing it up very well.
He became fascinated by potential parallels between so-called chaotic mixing of fluids and the mathematical functions that govern cryptocurrencies.
I was thinking, what are the simplest things that I encounter every day that have this property of being chaotic?
And that's when Gilpin started paying attention to what happens when he stirs creamer into his coffee.
When I stir it, everything I'm doing will affect the final pattern, but given the final pattern, it's hard to figure out how I stirred it.
And that, says Gilpin, is precisely how hash functions work in the cryptocurrency world.
Hashes allow you to create a representation of a piece of information that still hides what that information is.
Because, says Gilpin, they make it highly difficult for hackers to work backwards to get at the original information. Gilpin is hopeful that his observations might help computer scientists develop more advanced digital security by providing a useful natural model. His research is published in the Proceedings of the National Academy of Sciences. Jeff Bell, KCBS. Applied physics researcher William Gilpin has long been fascinated by potential parallels between the chaotic mixing of liquids and the mathematical functions that govern digital security.
I thought it would be really cool if something as natural and common as stirring a fluid and creating chaos that way had this analogy to the way that we're trying to stir up information when we encrypt it in a digital system.
So Gilpin began paying attention to the complex patterns that would emerge when he stirred creamer into his coffee.
Given that pattern, it's pretty hard to guess how I stirred it to make that pattern.
And yet, says Gilpin,
but if I were to stir it again using the same pattern, I get the same pattern again. So somehow it's repeatable, but it's not invertible.
And that repeatable but not invertible quality is just what so-called hash functions provide in the cryptocurrency world.
Hash functions create a digital signature of a piece of information that can be used to identify the piece of information without revealing what that information itself is.
Hash functions have become an especially hot research topic, and Gilpin is hopeful that his observations might help computer scientists evolve hashes by providing a useful model from the natural world. Gilpin's findings are published in the Proceedings of the National Academy of Sciences. Jeff Bell, KCBS.